Hello everyone, let's solve a problem from GATE 2011 Aerospace Engineering paper, question number 30. The question is a low speed wind tunnel has a contraction ratio of 14:1 and the cross-sectional area of the test section is 1 meter square, right? So usually our wind tunnel, typical wind tunnel will look like this. Okay, it is getting contracted. Let's say this is where we have a test section. Let's take this to be 2 and we have uh, another one is the settling chamber, so which would be somewhere here. So let they just take this section as 1, this section as 2. Okay, they're just saying like A1 by A2 will be 14. Okay, so our area of the test section is 1 meter square, right? So and then the static pressure difference between the settling chamber and then the test section is 40 centimeter of water column. So we have our pressure difference, static pressure difference between the settling chamber, which is 1, and the test section, which is 2, which is 40 centimeter of water column, right? So then what is this? Our row of water G and H is 40 centimeter, right? So this is what this P2 minus P1 is. Okay, so this H is what our 40 centimeter. Okay, let's just convert this to meter, which will be 0.4 meter, right? So what else information? Assuming G to be 9.81 meter per second square, rho of air is 1.2 kilogram per meter cube, and rho of water is 1000 kilogram per meter cube, and the speed of air in the test section is dash. So we have to find the speed of air. So let's take the speed of air at the settling chamber to be V1, the speed of air at this test section to be V2. Okay, now since considering that it is at the same datum level, let's apply Bernoulli's equation, right? So P1 plus half P1 by rho G half V1 square by G equal to P2 by rho G plus half V2 square by 2. So before that, let's use our continuity equation, which is A1 V1 is equal to A2 V2. Since we want to write find the settling chamber, that velocity at the test section, so let's write this relation in terms of V1. So then we'll get A2 by A1 V2. So A2 by A1 is 1 by 14. So the V1 is 1 by 14 V2. Okay, let's just substitute here. Let's cancel all the G's. Okay. So here the pressure is in the water column, but this row will be air. Okay, so our P1 minus P2 rho A would be equal to half V2 square minus V1 square, which is half V2 square minus 1 by 14 V2 square, right? So this rho P1 minus P2 is rho W, G and H. So our rho W, G, H by rho A. If I bring this 2 to the other side, and then if we try to take the LCM of this, then we will get 14 square, which is 196, right? So which is 196. Then we will have 196 minus 1. So what we'll get, we'll have 195 by 196. So if we just try to bring this to the other side, 195. So that's what our V2 square will be. So if we just substitute all these values, the density of water is 1000, G is 9.81 and H is 0.4 and density of air is 1.2, 196 by 195 equal to V2 square. So if we just try to find this value and take a square root of it, then you will get the value of V2 to be 81.077 meter per second. Okay, this is the velocity at the test section. Okay, so the velocity of the test section is 81.077, right? So if you want to know more about similar concepts of Bernoulli's equation, you can refer to the NPTEL course Advanced Concepts in Fluid Mechanics by Professor Suman Chakravarti in IIT Kharagpur. And the particular lecture for this question is lecture number 7 from this course, which is Bernoulli's equation. You can also see the YouTube link for the particular lecture here. So that's all for this question. Thank you.